Welcome everybody to another Weekly Squeak, twice in 1 week. So I really cannot be calling this the Weekly Squeak. It's whatever it happens to be. My guest on this episode is AB Periasamy and we did just discuss how to pronounce a company name, and it's gone completely out of my head already. MinIO.
That's right.
Yes, I got it. Good. So just first, very quickly, a little bit about you. Where are you joining us from? I'm guessing from the time, for me, West Coast, America.
Yeah, Woodside, California.
Okay, cool. And let's just do very quickly what the company is, and then I would just like to get a little bit about you. But let's hear a bit more about the company first. What is MinIO?
MinIO is an object storage. Think of AWS S3 is like a hosted service, and MinIO is a software. So you can deploy it on any cloud, whether it's public or private or edge.
And storage for what? I mean, maybe we'll get into the details of that a bit later, but storage can mean many different things. So what's it specifically storage for?
Yeah, I think you can fundamentally break the data into two types. One is the metadata, and then the other one is data, right? And metadata, usually you would store it in a database or a message queue. There are many kinds of metadata storage, whether it's a graph data or like a key value data. That part, I think developers understand quite well, that there are many kinds of metadata store. The blob store, which is you store blob of information, that is where the object storage comes. And what object storage replaces from a technology point of view, something that industry is familiar with, is a file system like NAS or a block storage like SAN. Block storage still has its place when it comes to accessing the physical media, but essentially file and block are getting replaced by object when it comes to application data, blob data. There are many kinds. The blob data is there everywhere, even for databases. How do you protect your data for database? Previously, database ran on top of SAN or NAS, right? Nowadays, if you see all modern databases, they are built on top of object storage. So object storage has become the foundational primary storage beneath many of these applications and other data services.
Okay. Let's get into that in a bit more detail in a minute. I'd like to get a bit more about you. What's your background, or what brought you to the idea or joining the company or whatever it may have been in the first place?
Okay. Yeah. So I would say I didn't want to do this startup. I didn't want to do any startup in the first place. I fell into startup accidentally because of open source, and I have strong principles towards what I do and how I do. And I couldn't find a job, so I naturally fell into startups, and from startups became an entrepreneur, but not by choice. Why am I doing it again this time? I only have my co-founders to blame. And it was because of them I'm doing it, but because I took the responsibility, I have to do it like you, whether you paid me or not, right? And my background is primarily in distributed systems. I used to be in the computing space, but it's kind of hard to make money paying your bills doing supercomputing. I used to be in the supercomputing space.
Feels like you should be able to, but okay.
There is theory and practice, right? Like my previous startup, we actually built the fastest supercomputer in the US. And it doesn't mean it will proportionately translate to dollars. But it was a fun one. But I fell into the data problem because of customers' demand. And for me, it's not like I'm fascinated by storage or distributed systems. Some problems were left unsolved, and it was simply an opportunity for me to go solve. And that's how I fell into it. But primarily open source distributed systems. And for last 10 years or so, I've been focusing more on the data side.
So let's now dig a little bit more into MinIO. I mean, maybe this might be kind of asking an obvious question, but it's always a good place to start. Is first, where does it fit? I mean, we kind of have in the title around like hybrid cloud and this kind of thing, but where does it fit into that piece of the puzzle? If someone is using hybrid cloud and Kubernetes and cloud native kind of infrastructure, where does it fit into all the pieces that you might need? Like what sort of application would need to use MinIO and things like that?
Got it. Yeah. So where does it fit? Like if you look at, like, say, what Kubernetes did to the computing side, right, in terms of generalizing the infrastructure through declarative APIs, when it comes to the data side, object storage has pretty much become the standard. And most people forgot that AWS started with S3 first, and then because of demand that they wanted to host applications closer to S3, and besides they like whatever AWS did, it's going to be cool. So they wanted AWS to also come into storage. So then came EC2, right? And MinIO's job is to go replace AWS S3 for the rest of the world. And when we started, it sounded obvious to me, but it wasn't the case when in 2015, right? But they thought that there was, public cloud means AWS, and when it comes to object storage, it is AWS S3. My point was that world is producing so much data, and bulk of the data is produced outside of the cloud. Only a tiny fraction of the data is produced from inside AWS. Then what will the rest of the world do? They're certainly not going to go to SAN or NAS, and the rest of the world will need an object storage that looks exactly like Amazon S3. And our point was, we can do one thing better than Amazon. They can do 1,000 things right. Certainly, we can do one thing better. And it sounded like it wasn't useful from general community point of view. Why would you build a AWS S3 replacement when there is AWS S3 inside AWS already? They didn't see the rest of the world. There was no Google Cloud or Azure Cloud. Even though they were there, they were dismissed, right? And private cloud, forget it. There was only VMs, files, and blocks. There was no Kubernetes, probably OpenShift, but they would dismiss it again, right? So my point was that first, we can build a better object storage compared to Amazon S3 because we are focused. Second, it will be useful anyway. It's just a matter of time they will find out. And today, actually, even inside Amazon, we have more than 3 million unique IPs running MinIO, but it's actually very popular all across, like in Google Cloud, Azure. Pretty much what we are now finding is Kubernetes has made infrastructure, a public cloud, as a commodity. What they want is kubectl, YAML, whether it's public cloud or private cloud or edge, they can control from their laptop. They're looking at Kubernetes as the one universal API. And while you see that now it's obvious. It wasn't the case when we started. And the same thing when it comes to data side, they want to look at S3 API, like the YAML for Kubernetes. When it comes to data, pretty much the applications have standardized on S3 API. While it's not exactly an industry standard, it's the popular API. And that's why it's a standard. It's not really standard, it's popular by choice, right? And this is where MinIO comes and makes AWS S3 compatible object storage. Wherever you are, it is like you would run your own Redis, your own Elastic, your own Kafka. Now, object storage becomes part of your stack. And where application developers are finding it really convenient is once they bring Kubernetes. In fact, the way they brought Kubernetes, by the time Kubernetes came, MinIO was already there. What they wanted was they modernized their application by containerization. Again, thanks to Amazon for forcing the cloud native design, educating the industry why this is superior. Once they were convinced, they brought containerization to their application. Once the applications were containerized, Kubernetes was inevitable. They want to orchestrate those containers. Then came Kubernetes. But by then, MinIO was already there because every application needs to store their blob data somewhere. Even if you have database, container images, logs, there are all kinds of data. They need to go somewhere, and the gold standard here is S3 API and blob store, and that's where MinIO became part of the stack. What the applications team or infrastructure team did not want to do was some part is running as containers, but some part is either bare metal or public cloud service. They were now stuck with one infrastructure. So they actually brought MinIO as part of the stack, so Kubernetes can roll out their entire software stack on any infrastructure commodity and gave them the freedom. I would say it's more so productivity and ability to seamlessly deploy multiple times a day. That drove this need more than they thought about portability as a priority. It came in as an afterthought.
one thing we haven't done very well so far is actually what is object storage? What do you mean by object storage? Just because there's these different sorts of storage types people might be used to hearing, a SQL database, a NoSQL database, a file database, all sorts of different storage things. What do you mean by object storage? Let's just clarify that quickly.
Yes, actually, it is something I would assume that everybody should know by now, right? Like, cloud is now so popular. It started with object storage in the beginning, and by now everyone should get it. But it's I wouldn't blame anyone. It's actually partly because of the age. Like conservative nature of the storage industry. If you look at even the Wikipedia pages about object storage, it's quite confusing because I
have it open and it is a little, yeah.
The reason for that is before object storage came, there was object-based storage, and that has nothing to do with object storage. I think the object storage idea is simply it's a blob data, any information that can be stored as a blob, right? It could be photos, videos,
binary data, yeah.
Binary data, right?
Things that isn't information, basically, yeah.
Right. In fact, it's not everything is binary, but binary data.
Yeah, I just realized the stupidity of the two things I said there, but it's fine.
like even when you call it unstructured data, right? Actually, it's not stupid because they would call blob data as unstructured data. But even in your file system, for example, if you look at the photos, videos, name it, log files, even an Apache log file, there is structure in it. Why do they call it as unstructured data? It is because unlike a database where you have a single schema that's uniform across all the rows, in a file system or in an object storage, there is no common structure. Every file can be it's not necessary. Maybe it's all photos, but it's not necessarily common structure across all the files or objects, right? That's why they call it unstructured data. But unstructured data can also be semi-structured, can also be structured, right? When databases are built on top of object storage, in fact, like Presto-like systems, Presto SQL can actually download these log files and index them in memory, whether it's Spark job, they would actually download a Parquet file, and Parquet object is basically structured content, right? You store pretty much all kinds of data. I think it's easier to say where object storage is not a good fit. Where it's not a good fit is if you are basically storing like kilobyte size or even like just like JSON documents, and your entire data is so small, and what you are looking for is like it's few bytes to few kilobytes, and you are heavily dependent on the queryability, right? That's where databases are a better bet, and you store tiny information, but more than storage, the databases excel in powerful query interface, whereas blob store or object store it excels in storage at large scale, but it has almost no queryability API. You don't have database-like interface. There is some exception there. There is a predicate pushed on. You can actually send SQL queries to the log file. You don't need to download. It's more of like a grep, a SQL grep, but ignore that for now. Database is powerful when it comes to query, and it's weak in storage. Object storage is powerful in storage, but weak in query. But then to solve this problem, I'm also seeing more and more that databases are basically now overlaying on top of object storage. So they let object storage do storage and database do query. And it's a good combination.
And I think Postgres do something like that, I think, from memory, or I can't remember. I feel like I've seen it somewhere, but
there is some. I would say there are some actually experimentations going on where it really started from the database point of view. The OLAP databases, analytics databases, they started first, and then because they experienced massive amounts of data, like data scale problems. Transactional data, like 1 terabyte Postgres database, is actually a gigantic database, right? Whereas in the analytics world, 1 terabyte is probably you begin with, and you see hundreds of terabytes to kilobytes. And the databases are now beginning, even the transactional databases, I'm surprised to see. I saw Intel and Facebook actually worked on MySQL backend where they would store the table segments of transactional database on MinIO, and the journal would go to Kafka. And I'm actually now beginning to see even the transactional databases are looking at object storage.
Yeah, I feel like I might have seen that in Kafka in the past, but yeah, it's been a little while since I've looked at Kafka. So just to clarify something here, because this is one of those, the whole kind of Kubernetes cloud native containers world, it's not as bad as it used to be, but there was always this problem with persistence because it wasn't really designed for that. So, and obviously object storage, if someone adds pictures, they kind of want to keep them. So does MinIO sit, I guess, kind of to the side of the Kubernetes cluster and things like that, and is persistent, or is it one of those things that somehow people are tearing up and tearing down each time, or is it kind of like a service that Kubernetes is connecting to in your case?
So the way you described it, right? That was how I thought about the storage too. I thought object storage would be outside of Kubernetes, where Kubernetes would just do the application containers because they are stateless and elastic, and Kubernetes orchestration is profoundly useful. So it was logical for me to think that way. But watching our user community, they actually understood these problems better. And also, Kubernetes itself is not tied to stateless applications. Kubernetes is a general purpose, like platform of platforms. You can, whether it's even VMs or containers, stateful or stateless, Kubernetes is one unified declarative API mechanism to deal with the infrastructure. And the stateful applications came later, and the stateless applications already took off. But the reason why the community wanted to run stateful applications like Kafka, Elastic, like MinIO, rename it, right, Cassandra, they wanted the stateful services to also be inside Kubernetes. Otherwise, what happens is you roll out your application, suddenly a whole bunch of essential services are outside. They may be running on bare metal, or they may be public cloud service. Now, the whole benefit of the containerization and orchestration is lost because you cannot roll out your software on demand. And what they wanted was, they wanted entire data center stack. The whole dependency chain should be inside Kubernetes, and they should be able to define their application stack in their YAML file and roll them out on public or private cloud. This case, you can clearly see, if that's your requirement, MinIO cannot be outside of Kubernetes. And then how does Kubernetes solve? What's the idiomatic way to solve this problem in Kubernetes? When it comes to stateless applications, it's pretty easy to manage. So Kubernetes already generalized that aspect. But when it comes to stateful services, let's take MinIO and say Cassandra side by side, right? MinIO does erasure code, so it can withstand multi-node failure. And even, like, say, for example, if you set like say 8 parity erasure code, I can withstand like eight nodes, but only I know exactly how many nodes I can tolerate depending on how the system is configured. Kubernetes does not have the context. Cassandra, for example, would be 3-copy replication. You can only take two node failures, but the 2 node failures, so actually you can do 1 node failure within the 3 copies, otherwise you will lose quorum, but you can do one failure across. So there are some intricate details that Kubernetes does not have the context when it comes to stateful services, right? This is where what Kubernetes did. It is a platform. It's a very extensible system. So it allowed these services to extend themselves in a way that they still look like any other service inside Kubernetes natively. And that mechanism is called the operator pattern. So MinIO operator would actually abstract these intricate details in a way that, from your point of view, MinIO would look like any other application container. You would just declare what you want, and the operator would set up the MinIO part of it. And the node failure, drive failure, how they get reprovisioned, when you upgrade them, when you update them non-disruptively. And also, another powerful thing the operator does is it gives you multi-tenant self-service model that when you keep provisioning new tenants, the operator can take care of it. Like multiple clusters can be managed on the same physical infrastructure. So operator is actually a pretty powerful pattern where Kubernetes allows vendors like the database vendors and the stateful vendors can write their own extensions in a way that they all look like any other Kubernetes service. Now, as a result, you have stateful and stateless services, all of them natively running on top of Kubernetes, and the benefits are quite significant.
I do think my reference is sometimes a little out of date on the whole stateful thing. It's definitely a problem that's been solved. I have also been doing a lot of work recently with a company that kind of maintains these sort of services that sit to the side of Kubernetes. Like you kind of keep them there running, and Kubernetes connects to them when relevant and things like that. Usually it's storage, but so I just wondered. But I just would like to dig a little bit more into the actual kind of project and company itself now. So what came first, the open source project or the company, the commercial product?
So if you see MinIO's case, for us, open source is a philosophy. In fact, I call it free software from the GNU project, right? Like there are two schools of thought, but for me, it's not open source. It's about practical and it's collaborative engineering. For me, I think it's more than that, right? It is for me. I'm doing this because first, when I learned about free software, it was a philosophy. It was a powerful ideology, right? That's what we were taught in schools, that whatever you learn, you share. And we progressed as mankind, I would say, are like both men and women, right? We progressed here by sharing and improving upon our ideas. So for me, it is a philosophical agreement, right? For me, that's how, if I don't do things that way, it doesn't seem right to me. And I told you early on, right, it's also my baggage that I have to do things that I believe in. And I felt strongly about it. And it's not just me. I think it's my whole team. They would say, they all came here because they shared that same philosophy. But independent of that, we still have to make money, right? MinIO is a business and it has to make money. But I don't believe that as a business that making money and sticking to your principles and doing what is right are orthogonal issues, right? You can still like every business, every brand has to do what is right and what they believe in. And brand is about making money doesn't give you the right to do wrongful things, right? So for me, it's not about law or anything. It's actually an ideological. It's a philosophy. So we always believed in it. And that's why MinIO was day zero, it was open source, right? When first code was committed, it was open source. And till today, it is the case. And I have no intention of making anything proprietary, because if I did any day, I lost my way. I lost my principles. I lost our identity, right? So it will always be the case. But we need to make money. And making money, I always found that holding customers hostage with license keys, I think those days are gone. Right? Customers pay you because you solve a problem for them and they believe in your brand and they want to establish a long-term relationship. And if you build a better product and if you build a relationship, if you build a powerful brand, you can always make money. And I found that open source actually did not come in the way. It actually helped me build a better brand. And till today, we actually thank open source. While we believe in it, it's also hugely helpful from the business point of view as well.
And I'm guessing from what you said and from what I understand that it follows a somewhat traditional-ish model for open source companies, in that you have the project that people can run themselves and host wherever, however they feel like it, and you offer a hosted version that is how you make revenue. Is that basically it, or is there something more to it? Or
it's not like that actually. End of the day, customers want to own the data, they want to own the technology, right? And they look at public cloud versus private cloud as just infrastructure. And when it comes to public cloud, it's a cheap infrastructure on demand for them, right? In fact, I wouldn't say it's cheap. Like nowadays they are saying that public cloud is more expensive than private cloud. But when it comes to productivity and ability to provision through an API on demand, I think that's significant benefit, right? The IT would take like 6 months to provision your infrastructure. So I think public cloud is here to stay and it will continue to grow. It's still in its infancy. But when it comes to the technology part, they want to own the data layer and the technology part of the stack. If they depend on the object storage from, say, one vendor like AWS S3, the moment you want to go to Google Cloud, you're stuck forever. You want to go to Azure or on-prem, anywhere, you're stuck forever. Many of these customers, they even wrote one version for AWS S3 and one version for on-prem. It just became too difficult for them early on. But they found that by making MinIO part of their stack, they can roll out on any cloud. And what they are paying us is very much for the software. And what are they exactly paying? MinIO is, while it's 100% open source, it's under GNU AGPL v3 license. And you are building a open source software under a compatible license. And if you can self-support yourself, it is certainly 100% free in terms of freedom as well as the cost, right? But majority of our customers, actually almost all of them, are building proprietary applications. And they want to get a commercial exception, linking exception. They want to get a commercial license so they don't have to comply with the open source license requirements. And in our case, we are the creator of the product and we own the copyright, so we can actually dual license it. So we gave them a commercial license. So what they're paying for is right to build commercial proprietary applications through the commercial license. And like any other software or any other product you buy, you expect support to come with it for free, right? Or at least included in the pricing. And that's what we sell. What you are buying through the subscription model is you are basically getting a commercial license plus support and SLA indemnification. It's like any other product you buy, a software product you buy.
And actually, I'm just looking at the pricing now. So there's a couple of other things here. SLA, yep, you mentioned. Support, yes. Security updates, yep. Panic button. What's a panic button?
We thought deeply about it. What should we call, right? It's easier to just say, make it obvious. It is it is literally like the name, as it sounds, it is a panic button. And what we call a subnet is a subscription network. Subnet is basically, right? It's an end-to-end customer portal, right? Typically, you would come into a Zendesk like ticketing system and you put in a request and then you get like within 24 hours, 48 hours, you get a response from a typical knowledge base from a level 1 technician. Those days are gone, right? And even if you took 4 hours for you to resolve these problems, your data infrastructure down for 4 hours, many of our customers can go out of business. And everything has to be real time. And even for the standard customers, while the SLA is like 48 hours, most of the time they actually get pretty fast response. And it's actually in minutes. And when you get the response, you want to actually hear from the guy or the girl who actually created the bug in the first place, or who understood the problem and is relating to you what you are explaining the problem and how fast we can solve the problem together. This is where we found that any of the traditional ticketing system, support system did not work for us. It has to be real time. And often, if you see the community Slack channel has 12,000 plus members, they got real time experience, right? And I need to do better for paying customers. That is where we built something that looks like Slack. It's real time, and it is a premium service for the customers with SLA backing, and also it's all secure communication. But more than that, it even has automated diagnostics. Because you're paying, as paying customer, you have call home, so we can actually know every detail about your cluster, right? What version you are running, it has known vulnerabilities or not, like critical bugs or not. You have problems in your hardware or slow batch, the new batch of drives are slow, all kinds of problems. We get access and we are able to do diagnostics. In spite of all of this, if there is a problem that we cannot solve, maybe it is a bug in MinIO code, or for some reason that you cannot explain, subnet automated diagnostics cannot explain, you hit the panic button, right? Or anything, or if even you don't have your service is down, it's a critical infrastructure and it went down. And you don't for you to not panic, right? You just hit the panic button. Panic button, in its simplest term, it's an instant SLA. You hit the panic button, everyone in the org across the globe will come online, and you are taken care immediately, right? We want to actually feel like we are partners in infrastructure management and operations. You hit the panic button. Actually, till today, every one of those panic button incidents actually are not our problem. It was something related outside of MinIO. But my point is, and even customers felt apologetic, like, sorry, we had to wake up the whole organization. It's not your problem. But our thing is, no, that's the whole point of panic button is sooner you bring to our notice, better it is. So we can together do a root cause. And if we are in a better place to help you, we are here to help you.
Sounds, yeah, it does. Waking up the entire company sounds like very dramatic. I'm sure, oh, sorry, it was an accident. It's like, oh dear. Oh, yes, okay. And I'm just going to clarify something for anyone else who's listening or watching, because it was something I had to clarify myself. It's sort of, you've been talking a lot about S3 compatible, and it was sort of something I had not really come across before. That doesn't mean you have to use S3. I had to clarify that myself.
Yeah.
There's actually quite a lot of providers. I find it almost a shame that a compatibility protocol is named after the original product. It's kind of like you're reminded of it the whole time. It feels a little kind of sneaky on Amazon's part, but they do a lot of things in that way. So we won't go there any further. What are some of the use cases that, like, common customers or common industries that you found people using this kind of product or project with?
It's actually all over the map. It is its strength and weakness. Object storage is actually a horizontal play. Because whether you are in healthcare or whether you are in consumer, like gaming, all kinds of stuff, everybody is producing data today, and they all need object storage. And it also puts a lot of tax on us that now, from a business point of view, it's easier to go one vertical at a time. But because of the nature of the object storage, it is actually horizontal. And open source helps us immensely, because by the time customers talk to us, we are already in production. They figured out how to do it. And I can't name off an industry vertical that would not need object storage today.
It makes sense. I kind of knew that would be the answer, but it's always worth asking. And as far as I can see, kind of in the past few months, you've generally been focusing on improving the subnet, the commercial side of things, and like health indicators for those. The Kubernetes operator is also quite new. 2 days, actually. So, I mean, before that, what was your kind of recommended usage with Kubernetes before the operator, or was it that that you just improved the operator recently? Maybe I misunderstood.
Yeah, so I'll explain what we are doing and why we are doing, and then I will go into the operator part, right? How the operator evolved. So if you see our focus in the recent times, almost like last 2 years, and it's now, I would say the next 3 years, I would continue to invest heavily on supportability. This is operational support, right? And I find that software itself, right, writing code is actually pretty easy, right? Because you're creating bugs. Fixing bugs is very hard. Finding them, fixing them, supporting them. Many organizations always thought, like, you even hiring QA engineers, someone who cannot become a software engineer becomes a QA engineer, right? And support someone who cannot. It's how the industry operated, and customers are frustrated with it, right? Actually, support is harder than even QA, and QA is harder than writing code. And for me, if we cannot operate at scale, we have a problem. The MinIO's strength is also its challenge. Because we have enormous community, right? And we opened up the subscription network, and customers are signing up like every day, every week. Like it's just now beginning to grow. And anything we do, we have to think at large scale. Otherwise, we would fail as an organization. The last thing I want is I took your money and I'm not able to take care of you. The brand falls apart, right? And the problem we have is we don't have much time, and we have to do it at large scale. How do you solve this problem? You have to invest in software to do all the things that software can do better than humans. Supportability is very much a software problem. And we invested a lot of effort in bringing supportability into the product itself, and also the stuff that we would do, some like in terms of support, operational support has to be digitized. And that, if you see, is where the subnet, all this health burden, health diagnostics to all of these capabilities came. So we can handle a large number of customers with the same level of SLA, same level of white glove service, the law way we call, and that will continue to be our priority. And now, while supportability is there is other part of supportability. Investment in supportability is reducing our load so we can handle large number of customers. The other side of the table, where customers are there, before an operator, you would hire DevOps, and DevOps actually like stick shift. They want to be in control. They like to script everything, and it gives them a job security too. Right? I think more than job security, I would say in the DevOps world, they love doing this. And it's control, and you can't argue with stick shift versus automatic.
Yep. Right? It makes you feel like you need it. Yes, I mean, it's kind of
understandable. You're in control. And I think every auto engineer will tell you that automatic has become so much superior that stick shift cannot beat automatic today. Right? It's true when it comes to infrastructure automation too. I think thanks to Kubernetes for consolidating around one framework, and now industry has accepted Kubernetes as the standard. Before, it was very difficult for us. There was Cloud Foundry, there was Mesos, Docker Compose, and Swarm. There were Ansible, like endless supply of these infrastructure automation frameworks. And Kubernetes gave a nice framework and declarative model that solved the problem for us. And then still what happened was, if you want to build a multi-tenant object storage infrastructure, before the operator, you would actually deploy you would write your YAML file. You will tell, here are, say I need 8 pods. Here is a CPU, network, and drives. You would create these CSI volumes or the persistent volumes, provision MinIO cluster, and you got a cluster running. Another application team came to you and asked, hey, I like that. Can you give me object storage too? You provision one more cluster. Basically, you have a collection of YAML files. You have 10 clusters, 10 YAML files. You want to upgrade, update. You're doing everything pretty much manual. Right? That's where GitOps comes. You're familiar with that model.
And I've seen the operator thing pop up more and more recently. Okay.
Now, where the operator comes, right? So the operator part comes and replaces a bulk of the job that DevOps used to do. Why is it important for us? Because I don't want customers to depend upon, right? While there are some customers who are pretty tech savvy and they like the control and they have that ability always, right? But we have better knowledge of how to do non-disruptive upgrades, how to do scaling, all of that. It's better to be a software problem, like it's part of the product, than I'm asking you to build part of our product, right? We have better knowledge and understanding. So by productizing the DevOps part of it, the human operator, by digitizing it, that's exactly what an operator pattern is, as the name sounds. It basically turns human operator, that is a DevOps job, into a product. But that way, now I can handle large number of customers who cannot hire DevOps. So it's all about scale. Our one theme, overarching theme between everything we are doing is how can we reduce the burden on the customer so they can focus on their business.
I like the way you also turn the kind of the scaling around a bit. Like most people talk about scaling their application, but you're making parallels between scaling the application and scaling your business, which is kind of interesting. And is that going to be the kind of next 6 months or so, the similar plan, increasing your supportability? Another phrase I quite like, you said. Is that going to be the plan for the next 6 months, I guess?
I think it's something. So even the operator, for example, right? Some of the core community members will be like, "What's the news? I've been using your operator, right?" The way we do, it's not only in the proprietary world. You do things in secrecy. You don't publish your roadmap, and you have this. You have basically everything is done in secret. So because your competition cannot copy, MinIO is pretty much an open book. Every code it goes. What we will probably talk about publicly, like from the press point of view, you would actually, if you watch our GitHub, the code would be there, right? The way we do. We do a lot of experiments. We also throw away a lot of code. We have a good part of our code, we throw it away because we see code as a baggage. But what the press release marks a statement that this is here to stay. This is the official approach. This is where all our investment will continue to evolve. And the operator, we started like watching how community started doing things like that and learn from the community, start investing and get a feedback like on a continuous rapid prototyping model, like on an iterative model you learn and let it reach a stage where, okay, now it sounds right. It sounds right to customers and users. This is here to stay. Now that's when we go talk about it. And that's how the operator evolved in series of micro experiments and it evolved a stage. Now I can say this is here to stay. This is official way of doing. Similarly, supportability will continue to evolve. I still find where we are, while we are ahead of others, we are still nowhere closer to where we want to be. I think supportability will always be an important part of the business. And I would say like even 3 years from now, if you ask me, I would say still we haven't done enough.
Well, that is possibly a good statement to end on. We should clarify the website is min.io, and obviously it's open source primarily. So I guess you'd have to have a good use case, but if any of this appealed to you, you can pop along and there's instructions in your documentation also on GitHub to get running on. In fact, you have, I think one thing I noticed, you have quite good support across the board. You can run on bare metal, which involves your local machine as well, Kubernetes, Docker. There's sort of a lot of options, and you also have a lot of SDKs in multiple languages as well. So those kind of integration points are pretty good across the board for the whole development stack. I think most of the code base is Go, if people are interested in contributing as well.
Yes.
And if anyone wants to reach out to you in particular, is there a method you prefer or not at all?
No, I'm here to help the community, right? So whether it is Twitter or LinkedIn or any means, like I'm all ears. End of the day, even if just hearing any appreciation, it makes us feel good, right? I would love to hear everything the community has to say, even if it is bad news. I would rather hear it first.